Hello and welcome to the 15th day of Advent of Cyber 2023. The task in question is about machine learning. Tagged blue, which means we will be on the blue team this time, and Jingle Bell Spam. Machine learning saves the day. So I will start the machine and we'll go through the different points. Problem statement. McSkiddy has been tasked with building a spam email detector using machine learning. She has been provided with a sample dataset collected from different sources to train the machine learning model. In this task, we will explore different steps in a generic machine learning pipeline, machine learning classification and training model, how to split the dataset into training and testing data, and how to prepare the machine learning model, and to verify that it's actually efficient and working as it should be. Okay, we are going to use notebooks. Jupyter notebooks we already did when we were working on the stats or analysis of the logs. The idea is that we will be looking into how we are able to build a pipeline for machine learning. So it's ingesting the emails, it's cleaning it, so data modifications or transformations to clean that, like if there is empty stuff, what should be put instead and stuff like that. Pre-processing is making sure that we are normalizing values and making sure that everything is standardized in a way that the model is expecting and not finding like infinity numbers or super high numbers or whatever. The modeling is basically what kind of algorithm will be used, and deployment is literally how it's going to be used in the real world. In this case, the email verification here. So we will be pulling the required libraries, which, as not surprising, would be NumPy and Pandas. And the idea would be to leverage a CSV file which has the email in it, and we'd be able to verify the dataset. So let's review the dataset we just imported. We have that one. So pum 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 pum. So we have CSV test emails, perfect. So the thing is already kind of split into two. We are going to import, and now we're going to check the data. The data is then spam, which is it has been detected as something not worthy, and ham, which is yes, that's fine. There's nothing really fishy in the text. We have data frames, which is the main data structure for NumPy and Pandas, and the display of the data frame is going to be providing us this classification. So here we're just using the head, but now we are transforming that data into a data frame, which is then indexed and all. For the data pre-processing, we are going to do correcting errors, fill missing values, boost the noise, and handle outliers. So is there any extra very big value or very low level, very low values and stuff like that? So all this pre-processing is part of the cleaning. We are going to normalize to verify to make the calculation in a more efficient way. Everything should be like between 0, 1 or -1 and 1. We are rescaling the data to have a meaning. And that's kind of like how we verify the outliers and all. The feature extraction is basically how we want to encode the different things that we want, or the traits or the features we want to engineer. The rest is kind of feature engineering, is like adding new parameters for identifying or helping trying to cluster stuff and being able to see patterns that normally you wouldn't see. Could be creating a parameter for the day of the week or stuff like that that will then show different patterns that you wouldn't have like thought about. Utilizing count vectorizer, that's where we are starting to use scikit-learn or sklearn. We are doing that to use to transform the text into something that is like numerical, and for that we'll be using the feature extraction text. So let's import that. It's now counting and everything is in X, and we have X being displayed here. Perfect. So now we're going to train the model. As last time, we're going to take an 80-20% split. So we're going to like import the train test split, and we're going to do the classification with that split of 80-20. So because the algorithm or the problem we're trying to solve here is pretty simple in the sense that it's either spam or ham. That's usually pretty narrow as in terms of like universe and calculation. And naive Bayes is one of those that make it super easy for statistic. It doesn't even need or could even not be qualified as machine learning per se, because we can have an implementation that is not neural network based, but here we are using sklearn, which is statistical, and so the idea is then verifying with that. So the bunch of emails are labeled spam and other ham. The algorithm will learn from these emails, and it will look for the words that each email calculates how frequently each word appears in the ham or spam emails, and free, win, offer, lottery, and all this kind of thing will be tagged as bad, and vice versa. And so based on this probability, you will be able to determine if the new text will be bad or not. And so for that, we are going to use the multinomial NB. So we have 99%, 94% for the precision, accuracy, pretty good. So if we test the model, today's offer claims £150 worth of discount voucher. Text yes to blah blah blah. So it looks like it's actually spam, and our model has been flagged it as spam. So great work. Now that we are aware that that thing is working, we should be able to make the modifications to help Max Kitty So Maxid has provided us with the latest email messages and asked us to test our model on these emails. Let's run our model on some test emails and see if it can detect spam emails. And so we have test emails CSV here. So I assume that is that one, test underscore emails dot CSV. Okay, we have data, and we are going to modify our X and get the result there. This is it from the task. From a practical point of view, we have to consider the following points to ensure the effectiveness and reliability of the model. Continuously monitor the model's performance on a test dataset or in the real-world environment. Collect feedback from end users regarding false positives. Use this feedback to understand model weaknesses and areas for improvement and deploy the model into production. So what is the key first step of the machine learning pipeline? We saw it earlier, it's ingestion. We saw it earlier, it's ingestion. Okay, I didn't see it was looking for two words, data collection. Okay. Which data pre-processing feature is used to create new features or modify existing one to improve model performance? We talked about it earlier. It's feature engineering. During the data splitting step, 20% of dataset was split for testing. What is the percentage weightage average of precision of spam? Weighted average precision of spam. 0.99. Oh, 0.92. Oh, wait. Did I misread it? During the data splitting step. Okay. During the data splitting step, 20% of the dataset was split for testing. What is the percentage weightage average of precision of spam detection? Maybe it was the one that was expected here, so 0.94, 0.98, 98 then. Okay, it was the one that was expected. How many of the test emails are marked as spam? Okay, we might be adding here a small recalculation. how many spam. Okay, so new prediction. That's this one. And so to go for the report, so the result data frame is actually 36, which means we have every count here. And so spam, we have 3 spam. One of the emails that is detected as spam contains a secret code. What is the code? And so reply with your name and address and you will alert. So if we look into the 0th, 5th, and 7th, so the secret code is I hate Bass Festival. I underscore HA capital 8 best capital T underscore festival. And there we go. It was a bit pushy, but we end up finishing the room. Thank you for your time. Um, look into the phishing module in order to look into different ways to detect wrong and malicious text and emails. And see you next time. Bye bye.